Hello everyone. Today I would like to present you a calculus project in which the topics related are trigonometry and related rates. The idea of this cool pool is that it is an automatic pool in which measures your height digitally, and once your height is known, the pool will calculate the water pump rate that will fill up the pool in exactly 5 minutes. The pool will be built in a rectangular shape and the dimensions are 3 meters high, 10 meters long, and 6 meters wide. Let me draw that real quick. Okay. So first we need to know the volume of this pool, which is volume is equal to width times length times height. And if we derive or differentiate this formula, then we will get another formula which is related to time. So we will get dv by dt, which is equal to width times length times dh by dt. Our dv by dt will represent the water pump rate. Width and length are area constants, which is why deriving the formula makes no change to these two. And lastly, the dh by dt, which will be the rate in which the water level is rising. The requirement for this variable is 5 minutes. Now moving on to the height measuring process, we have a grounded camera which is located 10 meters away from a fixed point. The swimmer will stand on that fixed point. Right there. And apparently our swimmer is Panalin. The grounded camera's job is to measure the angle of elevation. In this case, we will get an 8 degree for our theta. The theta will be further used to calculate the swimmer's height. By drawing this triangle, or which is based on the camera above, we will get the formula tan theta equals to opposite over adjacent. And if we plug in the known variables, we will get tan of 8, which is equals to opposite over 10 meters. Our opposite is actually the swimmer's height, which is 1.4 meters. We will then use this information to calculate for the water pump rate. Our pool needed to be filled within 5 minutes. So we will divide the height by 5 and we will get our dh by dt, or the level of water that is rising. Once we divide 1.4 with 5, we'll get 0.28 with it, which is dh by dt. The original formula is dv by dt equals to width times length times dh by dt. Now all we have to do is plug in those variables that we know. dh by dt that we found just now was 0.28. Width times length is 50 according to the pool dimensions. And then once we multiply them, we will get 14. And that is our rate in which the water is pumped. So the pool have many pros and cons. As you can see in our example, Panalin, who is only 1.4 meters tall, can finally hang out in the pool without drowning. It also saves a lot of amount of water at the same time. And the cons are that it is very expensive and more difficult to build.